Bismillahirrahmanirrahim. Assalamu alaikum students. Today I am going to introduce you to the course of this semester, second semester. So this is the introductory lecture. I have already shared syllabus with you in the WhatsApp group. So you know now your course is titles and electricity and magnetism. So this is the title of your course, Electricity and Magnetism. You know it is 4-credit course. And this course is divided into 4 units. Unit first, unit second, unit third, and unit 4. Now you are in second semester. Now we are going to take up unit 1 first, then 2, 3, and 4. We'll go in the order. And this unit 1, as you might have seen your syllabus, contains ideas like vector integration, line integral, volume integral, surface integral, and there are some theorems mentioned in the syllabus. One is Gauss divergence theorem. Then we have Stokes theorem. We have to discuss the idea of divergence, idea of gradient, idea of curl. Then we have to talk about electrostatic field, electric flux, Gauss's theorem of electrostatics, and we have to express this Gauss's law in differential form. So first I will refresh your memory regarding the idea of a vector. Then we will go through all the details of the syllabus. So let us do that. All right. So we are taking up unit first. All right. Properties of vectors. Now, from your previous classes, for example, you have gone through properties of vectors in your class 11th. So you know what a vector is. Any physical quantity which behaves like a displacement is a vector. This is the definition, right? So any physical quantity which behaves like a displacement is a vector. And you know, displacement is a change in position, right? But and you know what is a physical quantity? When we express laws of physics, for example, when we write Newton's law of universal gravitation, how we write it? We write F is G m1 m2 by r square. So m1 m2 is the mass of the two bodies, r is the distance of separation between them, and this law says that the gravitational force between the masses is proportional to product of the masses and inversely proportional to the square of the separation distance. G is a constant, as you know. So whenever we write any law of physics like this law, we write it in the form of an equation, and that equation contains certain variables. Force is a variable, m1, m2 are variables, and distance of separation is a variable. Now, these variables, which make up a law in physics, we call them physical quantities. So force is a physical quantity. Physical mass is a physical quantity, distance is a physical quantity. So sometimes we say physical quantities are building blocks of physics because we study laws of nature in physics, and laws we express in the form of an equation. Equation contains variables, and those variables are physical quantities. Now, these physical quantities we broadly classify, into scalars and vectors. Scalars have only magnitude, but vectors have magnitude as well as direction. And when we define a vector, we can define it in terms of displacement, because all vector quantities, whether it is force, velocity, acceleration, they are like displacement. So you can add scalars like numbers, you can use ordinary rules of algebra, but in vectors, there is involvement of direction. Due to that, there is involvement of geometry. And while dealing with vectors, you have to take that into consideration. So there are separate laws for handling vectors. Force is a vector, you know the examples. Force is a vector, displacement is a vector, acceleration is a vector, torque is a vector. There are many electric field, magnetic field, they are all vector quantities. There are scalars like mass is a vector, mass is a scalar, distance is a scalar, speed is a scalar. You know that. I'm just refreshing your memory. So we have physical quantities, some are scalars, some are vectors. We handle scalars differently, we handle vectors differently, because vectors have involvement of direction and geometry, right? So I gave you the definition of the vector. Now we move to the properties of vectors. We represent a vector graphically. So I will write first graphical representation. How we represent, so under this heading properties of vectors, first I write graphical representation. We represent a vector graphically by an arrow, right? With the condition that the length of the arrow is proportional to the magnitude of a vector, right? You know that. And arrowhead indicates direction, right? So rule is when we represent a vector, whether it is displacement, velocity, force, or any vector, when we represent it graphically by an arrow, rule is that its length is proportional to the magnitude of the vector and arrowhead indicates direction. And how we add two vectors graphically, once we have represented them using these conditions. For example, if it is my vector A and there is my another vector B, this is my vector B, I represented them graphically. So how we add them, how we find the vector which represents their sum. What we do, we place the tail of one vector on the tip of another vector, then the vector from the tail of first, that is this vector, to the tip of second vector, this is the sum. This is A plus B. So if you have to add two vectors, you represent graphically them by arrows using these rules. Then you place the tail of one on the tip of other vector, and from the tail of the first to the tip of the second, you get your resultant. This rule is sometimes called triangle law, or sometimes is always called triangle law of vector addition. This triangle of vector addition. So graphically, you can represent vectors, then you can find their resultant. This is also called resultant, that is sum vector A plus B using triangle law of vector addition. So let me move to the next thing. This is how we add vectors. Then equality of vectors. When two vectors are said to be equal. So two vectors are said to be equal when their magnitudes are equal as well as their direction is same. So two things, magnitudes equal and same direction. So when two vectors have same direction and they have same magnitude, they are said to be equal vectors. So vector A is equal to vector B when their magnitude is same and they are similarly directed. That means if this arrow represents vector A, and if this, let me use another color, this represents vector B, they are equal vectors because their length is same and they are similarly oriented. This is the idea of equality. Then we have the idea of parallelogram law of vector addition. Parallelogram law of vector addition. What is parallelogram law of vector addition? It's also simple. If I have two vectors, this is my vector A and it is my vector B. I have to find their resultant. This is my vector B and I am interested in finding the vector which represents their sum. What I do, I join their tails. First, I represent them graphically in accordance with the rules. I join their tails, then I complete the parallelogram. I complete the parallelogram like this. Then the vector emerging from the vertex where the tails of these vectors and B join, I draw a diagonal. That diagonal, writing, that diagonal gives me A and B. What we do, if I have two vectors A and B, we want to find A plus B vector. We want to find the resultant or sum vector. We join their tails and complete the parallelogram. Then the vector emerging from the vertex via the tails of A and B join, that diagonal gives me resultant. In triangle law, you can compare. In triangle law of vector addition, we join tail of B with the tip of A, and then the vector emerging from the tail of first to the tip of second is resultant. Here we join in parallelogram law of vector addition tails of A and complete the parallelogram. Now you can see what we are doing actually. You know, parallelogram has equal sides and they are parallel. That means by definition of equality, this is also B. This vector is also B. This vector is B because it has same direction as this B and it has same length. And similarly, this side of the parallelogram is nothing, it's A. So basically you are placing the tail of A on tip of B or tail of B on tip of A, and you are getting the resultant. This diagonal of the parallelogram is actually side of the two triangles. So this vector is also A and B, and this also B and A, B plus A. From triangle of vector addition, on the tip of B there is A, so this is B plus A. On the tip of A there is B, so it is also A plus B. That means in parallelogram law of vector addition, we are just using triangle law plus the property of equality of vectors. And sideways, what you get to know, A plus B is same as B plus A. That means vector addition is commutative. That means if you add A with B or B with A, you are going to get the same vector. So vector addition is commutative. So order of addition is immaterial when we are adding vectors, right? So let us move. This was number 3 into number 4. Vector addition is also associative. Vector addition is associative. That means if I have vector A, I add it B plus C, or I do this way, I add first A with B, then result I add with C. I get the same vector. Left hand side operation wise is different, right hand side is different. In left hand side, I am adding first B with C, then the result I am adding with A. In the right hand side, I am first adding A with B, then the result I am adding with C. But I am going to get the same vector. You can see that graphically. If this is my A, this is my B, this is my C vector. Let me first find the left hand side. So I have to add B with C. So I will use triangle law from the tail of B to the tip of C. This is B plus C. Now the tail of B plus C is at the tip of A. So from triangle law of vector addition, this vector is A plus B plus C vector. I hope you got it. I first found B plus C vector from triangle law. Then I am adding B plus C with A. So from triangle law, this vector is A plus B plus C. That's my left hand side vector. Let us find the right hand side vector. So in right hand side, I have to add first A with B. So from triangle law, let me use another color. In this color. This vector is A plus B, right? From the tail of A to the tip of B, this is A plus B. And you add A plus B with C in right hand side. So tail of C is on the tip of A plus B. So from triangle law, this is same. This is also A plus B plus C. A plus B plus C. What is the rule? Vector addition is associative. A plus B plus C is same as A plus B plus C. Right? So vector addition is associative. So let us move. So what we know till now, we know how to represent vectors by arrows. We know how to add two vectors using triangle law. We know when two vectors are said to be equal. We know how to use parallelogram law of vector addition. And we know vector addition is commutative. We know vector addition is associative. Now we move to next thing. Negative of a vector. Negative of a vector. What is negative of a vector? Negative of a vector is a vector which has same magnitude as that of a given vector but is oppositely directed. That means if this is A, minus A is that vector which has same magnitude as A but opposite direction. Right? So if this is, for example, A is force vector, it is 3 Newton due south, the negative of this vector is 3 Newton due north. So when we say some vector is negative of some other vector, that means their magnitudes are equal but they are oppositely directed. Sometimes A and minus A are called anti-parallel vectors. Anti-parallel vectors, right? Then there is another thing, subtraction of vectors. Subtraction of vectors. See, if this is my vector A, I want to find a vector which I obtain if I subtract another vector B from A. See what we do. In order to find A minus B, that means in order to find the vector which represents a vector obtained when B is subtracted from A, what we do, we add to A the negative of B. Because A minus B is A plus minus B. Understand it from this figure. If this is A, this is B. If I am interested to find A plus B, then this is my A plus B from triangle law. This is my A plus. Now, how to find A minus B? In order to find A minus B, I first find minus B. And I know minus B is a vector having same magnitude as B, but oppositely directed to B. So it is my minus B. Then I add this minus B to A. This A, on the tip of A, there is tail of minus B. So this vector, this is A, this is minus B. So this vector is A minus B. Because it is A plus minus B. Therefore, it is A minus B. Got it? So in subtraction of vectors, we use the idea of negative of a vector. This is A, this is B, this is my A plus B. But if I am interested in finding A minus B, I first find minus B, then I add minus B to A in order to find A minus B. So this is A, this is minus B. From the tail of A to the tip of minus B is representing their sum, that's A plus minus B, which is A minus B. Right? So let us move to next thing. 7th. What is the next thing? Multiplication of a vector by scalar. See, Scalars are of two kinds. One is just numbers, like 1, 2, half, 3/2, or they can be negative -1, -2, and so on. Second is scalars, which are quantities which have units. For example, mass, time. They are scalars, but they have units. They are just not numbers. For example, if you express mass, you will express it in, for example, kgs. You will write 2 kg, 3 kg, half kg. Same goes for time. 1 second, 1.5 second, right? So rule is, if we talk of numbers. If this is my vector A, I want to interpret twice A. What is twice A? Twice A is a vector which has magnitude double that of A, but is similarly directed, right? So rule is, if you multiply a vector by a number which is positive, the resultant quantity is vector in the same direction, but that number scales the magnitude of the vector. Half A is similarly directed as A, but it has half length, right? If you find minus half A, it has half length as A, but it is oppositely directed with A. So when you multiply vector by a number scalar, the resultant quantity is a vector in the same direction. If the scalar is positive, it is a vector in opposite direction. If the scalar is negative, and the magnitude of the resultant vector is scaled by the magnitude of the scalar. That means half A is half of length of A, twice A has length double of A, right? But since these numbers have no units, whatever the unit of A, same goes for 2A, half A, or minus half A. That means when you multiply vector by a number, its nature doesn't change. What happens with these scalars? For example, if I have velocity, I multiply it time. Time is a positive scalar. So this quantity is a vector in the same direction as that of V. But what is different here? Now, TV or VT is not velocity, it is displacement. Because here you have to take units into consideration. Velocity has meter per second, time has second. When you multiply VT or TV, product has units of length. So it is a displacement vector. Likewise, if I multiply acceleration vector with mass, mass is a positive scalar, ma is a vector in the same direction as that of A, and it has magnitude equal to magnitude of m times the magnitude of acceleration. But this quantity is now not an acceleration, it's a force. This unit of mass is kg, unit of acceleration is meter per second square. So it is kg meter per second square, which is Newton. So it's force. It's force. So I hope you got it. When you multiply vector by a scalar, you get a vector. If these scalars are just numbers, nature of the vector remains unchanged. If these scalars have units, nature of the vector gets changed. If the scalar is positive, the resultant vector is in the same direction. If the scalar is negative, the vector reverses the direction, and the magnitude of the vector is scaled by the magnitude of the scalar, right? There is another thing, we define a unit vector. Unit vector is by definition a vector which has magnitude of 1. A vector which has unit magnitude and is dimensionless. It has no dimensions. A vector which has unit magnitude and is dimensionless is a spatial vector called unit vector. It has a spatial symbol. For example, if I write vector A, how we write these vectors? Till now, we place arrow above. And in print sometimes, we write them in bold. that means a vector. If I do not place arrow, it indicates the magnitude of this particular vector A. Or I don't use the bold letter, that means it is representing just the magnitude of it, right? Unit vector has different notation. I write, if A is a unit vector, I will write this hat, or it is read as hat or cap. So A hat, when I write A hat or R hat, S hat, that means it's a unit vector. It has magnitude 1, it has no dimensions, right? And you can define unit vector in any direction. You have to specify that. For example, sometimes I may say let R cap, let there be some vector A in certain direction having certain magnitude. Then I define R cap be a unit vector in the direction of vector A. You can define unit vector in any direction. Then you can write this vector A as magnitude of this vector times the unit vector in its direction, right? I'm saying unit vector has some definition which I have given to you. It has unit magnitude and it is dimensionless. You can define it in any direction. Now, if suppose there is a vector A and you define a unit vector R cap in the direction of A, then you can write vector A as its magnitude times the unit vector in its direction. So in other words, that means unit vector in the direction of A can be written as vector A over magnitude of A. Right? So if you are given a vector and you are asked to find unit vector in the direction of that particular vector, what you do, you divide that vector by the magnitude of that vector. By that, you will obtain unit vector in the direction of that particular vector. Right? There is another thing called zero vector. Write it clearly, zero vector, or we call it null vector. Null vector. What is zero vector or null vector? A vector which has zero magnitude. A vector which has zero magnitude. When it has zero magnitude, there is no question of direction. Because it is vector, when vector has length, then we ask in which direction it is oriented. So a vector which has zero magnitude, there is no question of direction. Then what is the fun of defining a zero vector? See, in numbers, if I have 3, I add to it -3, what I get? 0. So -3 is called additive inverse of 3, or 3 is called additive inverse of -3. Likewise, in vectors, if you have a vector and you add negative of that vector to that vector, if you add negative of A to A, what you get? You get vector, but that vector is zero vector. You write 0, then you write vector, or you sometimes write it in bold, right? Similarly, if you add 0 to any number, that will not affect its magnitude. 3 plus 0 is 3, or 0 plus 3 is 3. Similarly, if you add 0 vector to any vector, you get that vector back. So 0 vector has the same meaning in vector algebra as 0 has in numbers. So if you add negative of vector to a given vector, you get 0 vector. If you add a 0 vector to any vector, you get that vector back, right? So let me check whether we have done it or not. So we know now what is a vector. We know how we represent vector graphically. What is parallelogram law of vector addition? What is triangle law of vector addition? What is equality? Vector addition is commutative, it is associative, and we know how to represent a vector. We know what is negative of a vector and how negative of a vector is used in subtraction of vectors. We know when we add, multiply vector by a scalar, what we get and how we do that. We know now unit vector idea. We know this idea of zero vector or null vector. So this was refreshing your memory about the properties of vectors. This all for today. Go through the syllabus. Don't waste time. Go through all the lectures and enjoy these lectures at home. And don't forget to like, share, and subscribe my channel. Subscribe my channel. You can comment in the comment box as well. Thank you. God bless you. Assalamu alaikum.